morning, all of you.
Morning.
Respected Sandeep sir, Shraddha ma'am, our team mentors, and all my dear friends. My name is Prakhar Barnwal, and I am from MS21 BIM with project management. Yeah, I am also the group leader of my team. MS is in group 2. Yeah, this is our group. Master study in group 2. Where we have faced 48 hours challenge. Next. Yeah. Our team mentors are Mr. Sandeep sir, Mrs. Shraddha ma'am, and Prakhyat sir, Abharna ma'am, and Mukarram sir, Swapnil sir, Tathagat sir, and all my dear team mentors. Now, I am going to describe our team members. There are total 10 members who face 48 hours challenge based. I am Prakhar Barnwal, project manager of my team, and Advait, BIM engineer, Shekhar Samjos, BIM engineer, Prasanna, and structural engineer, and Pradeep Chand, Satish Sharma, Mayur Undre, all are structural engineers in our group, and Mohammad Mahir Rahul Singh is a value engineer in my group. Next. Not that one. Next. Now I am moving on my projects. My projects, Mumbai projects, this is situated on Mumbai G+25. Total cost of the project is approximately 38 crores, and height, length and width of the project is 81.2 meters, 31.83 meters and 25.66 meters, where we have used M30 and M40 grade of concrete and FE 550, 500 and 415 HYSD high yield strength steel bars. Next. Yeah, I am presenting some rendered view of my team projects. Please have a look. Yeah, this is our living room view. Bathroom view, rendered view, and kitchen room, rendered view. Bedroom view, and living room view. Again, yeah, this is a section view of my project. Yeah, this is the elevation view of my project. Door schedules, and this is a window schedule where in door schedules we have put it 5 types of doors, means 5 types of sizes of doors, where we have used only panel wood doors. This is very economically, and also we have used total 2 types of windows, 2 size of windows, where we have used only transom windows. Yeah, ceiling schedules and floor finishing, where ceiling schedules we have used only gypsum board ceilings. This is also economically and fire resistance ceiling boards. And in bedroom, I have used wood floor and ceramic tiles in bathroom, kitchens and living rooms, where the thickness of this floor finishes is 30 mm.
Thank you, Prakhar. Good morning, everyone. My name is Mayur Undre. I would like to thank to Sandeep sir, Shraddha ma'am, and all mentors, also my group members, to given me an opportunity. Now I move on architecture plan. Our building situated in Mumbai is a G+25 structure. We can see that there is a 6 1 BHK flats and 6 room kitchen flats in each floor, and also we can see there are 2 normal elevators and 2 passenger elevators, and also there is one stretcher elevator and 2 staircases. So the built-up area of each floor is 6,135 square foot. Next. This is our superimposed plan. We obtain superimposed plan by superimposing architectural plan over the structural framing plan. With the help of this plan, we can see that there is no any structural elements obstructed in architecture plan. So next. The structural framing plan, we can see that after obtaining the architecture inputs and instruction given by our team members, I focus on every structural member is like a beam and column is properly connected to each other, and also we place my-one wall and shear wall in external side and column internally. And also we can see the grouping system. We use the grouping system of beams. That's all. Further slide I invite Prasanna to continue. Thank you.
I'm Prasanna and I'm a trainee at eConstruct. So I have worked on the structures of this building. A very specific and important thing about this structure, a special thing about this structure is that we have used my-one wall in this building. So I would like to start by telling you what my-one wall is. So my-one is the name of a company which produces aluminum foam works, and so these foam works are used for construction of the walls. So the initial stage of constructing a my-one wall is setting up the wall reinforcing steel. So my-one wall is a RCC wall which has reinforcement in it. Okay, so the initial stage is we put the reinforcement. So the second thing would be placement of the aluminum foam work. So after placing the reinforcement and specific covers, so we provide the foam work, and so later we pour the concrete. So here one thing is that we cast these beaming walls and the beams and slabs like monolithically. So there is a lot of advantages with this structure. So as this is a new concept, I would like to tell some merits and demerits about the median walls what we have used. So speaking about the merits, these walls, they are seismic resistant. So I've already said that these are reinforced walls. So obviously they are seismic resistant structures, and they are durable. So Mumbai is a coastal area and it is prone to a lot of environmental changes. So we have placed all these median walls in the exteriors of the building, that is for the main exterior main walls. So it will provide durability to the structure. Reduces construction times. So you all know that there is a lot of time consuming in building the masonry walls. So this my-one wall structure reduces the time consumed to construct the structure. Reduce requirement of skilled laborers. So there is not like to build a masonry wall, the specific masons who are being in that field for quite a long time are required to construct the masonry walls. But these my-one walls, since all the formworks are factory made, so they can just be assembled, and it's not like we require skilled laborers there. Negligible labor intensive work. Smooth finish, limited wastage. So we can see when we build the masonry walls, so there are many uneven structures, many unevenness in the walls, right? So that can be avoided while we use this my-one wall. And the limited wastage. So while construction of the masonry wall, we see that a lot of mortar is wasted, and during the plastering also there is a lot of mortar being wasted. So that can be reduced in this construction. There are also some demerits. Visible finish lines. So this can be taken care during the painting work. Less scope for modification. So once these, as I said, these are RCC walls. So there is no point that we can modify this after the construction is done. So that is why we have considered this my-one wall structure only to the exterior of the building. Requires uniform planning. So our architectural plan is such that we have a typical floor plan for all the 25 floors, and that is not an issue with us. Can have contraction cracks. So we can reduce these contraction cracks by reducing the heat of hydration in the concrete. So that we can do by using a design mix where we use fly ash in it. So that can be done. And one of the main demerit is that these my-one shuttering is quite costly. It is very costly compared to the normal construction. But since our building, the structure has 25 stories. So if we cross 21 levels, the cost becomes efficient. I can explain you how. The construction cost. So the construction cost goes on increasing as the time increases. So here what we are doing is by using my-one walls, we are reducing the construction time. So we are investing in this, but we are reducing the time, and that is how we are saving the construction cost. So the software what we have used to design and analyze this structure is ETABS. So ETABS is one of the FEM softwares. So finite element software. It is also used to construct the iconic Burj Dubai. So that we have considered in our project. Okay, modeling in ETABS. Referring to CSI knowledge base, so we came to know that we can model my-one walls in ETABS. This type of system can be modeled in ETABS as shell objects. So we have considered thin shell element. A key concern when modeling my-one system includes location where these interconnecting shells transition into transfer girders and supporting columns. So what we have done is we have designed these my-one walls as shell elements, and then we have wherever there are columns coming in between these my-one wall structures, we have designed them as shell elements only. Like we have considered columns as area elements, not as line elements. And to achieve proper connectivity, we have meshed them properly. So once we model these in ETABS, what happens is ETABS considers this as a structural element, but in reality they do not act as a structural element because the reinforcement given in these my-one walls is very minimal, which cannot act as a structural element. So what we did is we applied the SMF, that is we cracked the model, applied the following SMF, and then in the uncracked model itself. So that is how we have considered it for analysis purpose. Okay, so as I said before, so these are the my-one walls, and so these are the my-one walls in the exterior structure, and these are the columns what we have designed as area elements, and these are the SMF that we have applied in the uncracked model only. So this is the view of mathematical model. You can see all the exterior walls are my-one walls. This is a structural rendering view. So as I said, we have meshed the model properly. Okay, material specifications. Since we are constructing this structure in Mumbai, so the minimum grade of concrete we have to use is M30, and we have considered that. And for columns, we have considered M40 grade of concrete. And the grade of steel used is Fe550, Fe500, and Fe415. So these are the beam sections what we have used. We have tried to use the specific structural elements so that we don't increase the dead load on the structure. And the my-one walls what we have considered is of thickness 160 mm. And shear walls we have considered around 300 mm thick. So these are the loads, shell loads what we have considered. General 1.5 and the live is 2. For lobby we have considered 1.5 as dead and 3 as live load. For WC we have considered 3 kN per meter square as dead load and live load is 2 kN per meter square. For terrace we have considered 3 and 3 in both the cases, dead and live. And for OST we have got 20 kN per meter square as dead load. And for LMR we have got 10 kN per meter square. So these are the load calculations what we have considered. For terrace, for OST as explained before, and lift machine rooms. So the frame loads what we have considered is for Maiban walls we have not considered any load, though we have placed the beam because itself considers the dead load. So we have not considered any dead load separately for this. But for the internal walls we have considered a dead load of 4 kN per meter. So seismic analysis part will be presented by my friend Bob.
First of all, good morning everyone. My name is Pradeep Chandra and thank you for giving this opportunity, and to ma'am and sir, thank you mentors and my friends who have helped me and guided me in a correct way to complete this project. I want to tell about this seismic analysis. As I am a structural engineer, I want to explain the analysis part. As the building is in the Mumbai region, we have taken the zone factor as 3 as per ISI 1893, which is the value of 0.16, and soil type is 2. Important factor is 1.2 because the population is about 200, and response reduction factor is 5, which is taken from 1893, and time period in x direction is 1.29 and y direction is 1.4. And these are the base shear values in the dynamic analysis for spec X and spec Y. And these are the wind analysis part, where the wind speed is 44 according to IS 875. Terrain category is 2. Importance factor is 1, risk coefficient is 1, and topographic 1, which is taken from the IS 875. And wind analysis, we have done wind gust factor, where it is done by IS 875, and the formula is Fz equal to Cd into AE into Pz into G, where Fz is the wind load and Cd is the force coefficient and AE is the effective formal area and Pz is design pressure and G is the gust factor. And these are the values which I have got from the gust factor. And this is the model analysis, where we got for in first mode we have got the time period as 2.6 and rotation as 2%, with the translation mode in UY direction 71%, and in second mode we got the 2.1, and at the third mode we have got 65% above in some UX and some UI, and at the last mode we have got above 90%. And these are the stability checks for the model analysis part. And this is the deflection check which I have done in my project, where we got the deflection in terrace floor. So what we got in this, the span length is 3 meters, and calculation is like allowable deflection is greater than the actual deflection, hence it is vast. And these are the stability checks for inner story drift, where it should be less than 0.04 in spec X and spec Y direction, and in displacement, maximum displacement against wind allowed in H by 500 is like it is passing, and in maximum deflection against earthquake H by 250 again it is passing. And this is a torsionality check which is done in strength model. These are the results which I have got in the torsional irregularity in spec X direction and spec Y direction. And another check is done by soft story. This is a soft story. This is soft story of the building. This is a soft story check in our building in SpecX direction, which I have got regular in all the checks. And this is in SpecY direction. And this is a buckling check where we didn't want any buckling is not required. And for the design part, we have used load calculations where all frames are passed due to it. That's it from me. Thank you. Next, my friend Shekhar will proceed.
Good morning, all of you. Good morning, sir. Good morning, ma'am. Good morning to my mentors and my friends. I am Shekhar Santos. I'm the beam modeler for this company. Moving on to the structure of BIM model. This one is a rendered view of the structure 3D model. And this one is a structure typical floor plan, which is having the beam sizes and column size and shear wall and Maven wall, which was explained by Prasanna, my friend. And moving on to the electrical, this one is the electrical 2D plan in which we have provided lighting, minimum lighting for all of the rooms, and also receptacles including kitchens and bathrooms. This one is a electrical elevation for. This one includes position of the transformer and the diesel generator, in which we are using a transformer of 150 kilowatt and generator of the same 150 kilowatt. Moving on to the next one, that's plumbing. The contents included in the plumbing are overview of the plumbing system, then the hardware brands used, the pipe specifications, pipe materials and pipe schedules. This is a typical plan for the plumbing. 3D of the plumbing of the whole building. This one is a section view of a single bathroom with details, which is having the blue one, which is for the cold water supply, red one for the hot water supply, and green one for the drainage and sanitary. In this one, you can see the wall mixer blend, which is having a height of 1.2 meter from the floor, which is a standard height, and wash basin having a height of 0.9 meter from the floor, and also the geyser, which is 1.8 meter from the floor, which is a standard height for everything. This is the 3D view of the bathroom plumbing. Moving on to the hardware brands used, Bradford White is used for the water heater, which is also wall mounted, and Crompton, which is the pump set used. Hindware is used for water closet and flooring. Jaguar is used for water tank, showers and faucets, and the pipe we are using is Astral pipes for pipe fittings and PVC pipes. This is our OST position plan view, in which from the overhead tank we are having an outlet of 15 mm diameter pipe, which is given on one side, and the inlet pipe, which is having a diameter of 50 mm, which is coming from the pump room. This is the position for the sometime and the septic tank position. In between is the sometime, and on the both sides the septic tank is given. Into the sometime, the municipality connection is given as 50 mm diameter of pipe, and nearby the sometime a pump room is given, in which dual pumps are given, and one from the sometime and one from the OST, or going to the OST, which is having a 50 mm diameter. Discussing about the overhead tank, the tank is rectangular and is divided into two parts, so that we can give it to the two directions of the building, and outlets are also taken from the two sides, and overflow pipe is also given to the sometime, so that none of the water will be wasted. and automatic water tank level monitoring and controlling system from the graphite tank company is also given. And overall, the overhead tank is having a capacity of 3,65,500 liters. Sometimes it is located below the ground level, and municipal water connection is also given, and two-stage filtration, one for the temporary hardness and one for the sediment. And water level monitoring system is also given for the sump tank. Materials used are PVC is used for both hot water and cold water supply, and also for the sanitary or the wastewater. The diameters used are 15 mm pipe, 32 mm pipe, 40 mm pipe, and 100 mm pipe. 15 mm pipe, which is used for cold water and hot water, and 32 mm pipe is also used for cold water and hot water. 40 mm pipe is used for kitchen sink, the drainage of the kitchen sink, and 10 mm pipe is also used for the drainage. And the slope of the pipe is given as 1:12. The pipe joint, for the pipe joint fixing, we are using solvent cement from the company Finolex, and Teflon tapes are used for threaded pipe fixes. This is a water drain or return. For water closet, wash basin, kitchen sink, and floor drain, we are using 10 mm, 32 mm, 40 mm, and 50 mm respectively. For the water supply points in the kitchen, we have given cold water supply for the sink, and 1 point for the water filter, which is using GI pipe. And the bathroom for the basin, cold water supply, and hot water supply points are given. And for mixer and process, cold water supply and hot water supply. And we are having a flush tank point, which is having a flush tank capacity of 1.6 liters per flush. Water heater we are using Bradford White, which is also one mounted heater, and having a capacity of 22 liters, and voltage is 1500 volt. And the temperature which we can maximum attain in the water heater is 55 degrees, which is having a special features like temperature display and auto cutoff. Talking about the water pump, we are using Crompton, which is a single stage pump for high head. And check valve and foot valve is given for checking the water pump to be flowing back into the basin, and for preventing the flow back of the water. And 6.3 liters per second is the capacity of the water pump, which is having a 75 HP. Pressure regulator and stop valve is also provided since it's the overhead tank is located above 25 floors. Pressure regulator is given for every home, so that none of the plumbing fixtures will damage. It restricts the pressure to the safe level before entering into the plumbing fixtures. And talking about the stop valve, for reducing the entry of flow to the home, we have provided the stop valve so that you can repair it after shutting off the stop valve. Water treatment plant is also given only for the treatment of the grey water, which is coming from wash basin and sink. And the grey water is used for the planter box and gardening, and thus we can use the grey water as we use. Economy. Talking about the economy, wall brackets are used so that the wall will not get contact with the pipes. So contiguous pipes are having a distance between them, and we have also maintained a maximum distance between the return and supply pipes. And we have also used an economical pipe layout so that minimum length of pipe is used. That's how we can reduce the cost of the pipe. That's all from my part. Now I invite Prakhar for more details. Thank you.
Yeah, of course. Thank you, Shekhar. And as I am a project manager of my team, I have to discuss about all the aspects of the project. Now, I am discuss about this bill of quantity (BOQ). This is done by Mr. Rahul Singh, who is a planning engineer and value engineer of my team. Yeah, the total cost of the project is approximately 38 crores, but the typical floors plans, whichever is going on, that is approximately 1 crore 67 lakhs. Next. Yeah, this is a timeline of my project where I have to execute this on the site. This next. Yeah, next. Overall, the time taken by this project is 2.5 years, and execute by this on the site is total approximately 3 years. At last, I would like to first of all sorry for my team members because I don't know what is going on at the start because while getting this mic, I am so nervous really after 2.5 years, and now I am feeling just vibrating in my body. So that first of all, sorry for our team members because they really give a lot of efforts in this project. And also thank you for all team members and team mentors and really Sandeep sir and Shraddha ma'am because without you we can't able to do like that type of projects and not what this is also vibrating like that. Reality is, and starting what's going on really I don't know because after at least 2.5 years I have taken this mic because in the previous 6 months I have done that marketing works, but I don't know what is going on. But thanks a lot, all of you. Thank you.
Yeah, some questions actually. What is the cost rupees per square foot? Rupees per square foot.
1500 construction with material.
Okay. Overall, actually, see, I have seen that my one wall explanation and the kind of CSI knowledge base you have got, the kind of the different plumbing and the electrical fixtures that has been explained. Because really, I mean, the kind of details were there in the slides and those are really very impressive. Few things actually you have gone through the gas factor calculations. There's so many other things also you have got. I mean, I was curious that single stage pump is enough actually for 25 story to take it up.
Dual stage. We are using dual stage.
A 12 stage, is it enough? Or, okay. What was the HP you used?
75.
75 HP. Okay. Fine. So overall, it's really fantastic. Thank you very much. Thank you.